or am I? Oh, it's still not going live. Oh, it says now you are live. Okay. So not sure if you have heard that or not, but I guess I'm live now, right? But yeah, that's not visible. Cool. So it's just that, like, the only reason I'm starting a bit early today is just because I have a very critical task to do, and also I know that the entire week is very hectic. I cannot get time in that. So like you guys usually say that what about after the work and something like that, but with managing the daily videos with live stream again for the next week also, so if we procrastinate any of the stuff, for sure nothing will be done. So it's the reason. No worries that if you cannot watch it live, let's say. And first of all, whosoever is watching live, can you please quickly have how are you, hello, good morning, and also how many questions you guys were able to solve. It was nearly same as that of the yesterday's contest, which is the previous contest, but bi-weekly something. It was more or less same, but yeah, cool. Let's quickly start off. Sorry for that page. It's a page. It is just linking memes with the fun educational content, because that's how you will not get bored. Cool. Now we'll start off with the problems. Let's quickly go, and again you can just push your doubts. We will go on to all the doubts in the mid also and in the end also. But if you are watching, if you are the regular ones, can you please smash that like that was super great. Cool. Count tested devices after test operation. It just says that we are having a zero index array called as battery percentage. So I have a battery percentage array, and which is having a length n, and it denotes the battery percentage of n devices. So basically I have an array of length n which indicates battery percentage of n devices. Now the task is to test each device I in the order from this, which means I'll go on from left to right itself. That is the order which I have to go to. Cool. Now when I will do a test, what I'll do, which means the operation or the test which I need to perform is, if the battery percentage is more than 0, again, if the battery percentage is more than 0, then okay, you have tested this battery, okay, tested the particular device, that's great, and then decrease the battery percentage of all the devices on the right of this ith device, decrease the battery percentage by 1. But if it is a 0, then make it a 0, like keep itself as a 0, don't decrease that further itself, don't make it -1. If it is a 2, decrease to 1. Basically if it is a non-zero value, decrease it by 1. If it's a 0, make it as a 0. That is operation number 2. And basically after that, when you have tested the ith device, which means when you have taken, and you can only take when its battery percentage is greater than 0, and when you take it, you will just make sure that all the remaining devices, which is I plus 1 up till n, you make all of their battery percentage decrease by 1. And when you will do this operation, you will hello Manu, hello Shashank. Manu, like yesterday I saw your LinkedIn, so like usually it is how things work, that like usually if I just have some notification and remember the names, so usually I accept pretty fast. So yeah, like yesterday many of the people who were active on chat shared the request, LinkedIn request, so it was very easy for me to actually just click connect. So yeah, if you are also vibing on live chats, just quickly you can just ping me on LinkedIn after this live stream, so it will be much more active. Cool. Now going on back, I'll just decrease the percentage and then move on to the next device. Now otherwise move to the next device without performing any test, which means if the battery percentage is 0, then don't move on. Like basically you can move on to the next device without even consuming that battery. Consider, okay, I had never consumed that as a test. Now after return the integer denoting the number of devices that will be tested after performing the test operations. The only problem which has so big description out of all 4 problems is this one. Can you just imagine, the easiest problem has the biggest description? That's pathetic. Cool. Now as you can see, I'll just consume this one and I'll decrease the remaining ones by 1. right? I cannot consume this one because it's 0. I'll consume this one. Okay, cool. Then I'll decrease the remaining ones. Okay, I cannot decrease this. I'll decrease this. Okay, that's great. I cannot consume this one. Cool. I'll consume this one. So answer is 3. So it's just that consume, and for sure for the remaining ones make it decrease by 1. Now one way is you can do it in 2 passes, which means you can do it in O of n square, which is the brute force, which is for sure will work considering the constraints. But you can also do the same thing in 1 pass. How? You know one thing, that as soon as you will take this, as soon as you will take this, you will decrease all the remaining ones by by 1, because you have taken 1. So I'll decrease the remaining ones. If I just make it as a zoom, so if I take this, I know I'll decrease all the, let's say my answer is 1 right now because I have taken this one. So I will not go right now on all of them. I'll just remember, okay, I have taken 1. So in future, if I am taking anything, I have to first decrease and then check. Okay, if it is more than 0, then I'll take it. So next time I am at this location, I'll firstly decrease by the answer and then check if it is allowed to take. Okay, as soon as I decrease by the answer, it has become 0, so don't take it. I reached here, I decrease by the answer. Okay, I still have 1, so I can take it. As I take it, the answer will increase to 2. Okay, cool. Then I have taken this. Now as I came here, I'll say 1 minus 2. It became minus 1. So for sure I cannot take it. Okay, cool. You cannot take it. Now move on next. 3 minus 2, 1. Yeah, I can take it. Okay, cool, take it. Answer is 3. So with this, with 1 pass, you can easily get this solved. Cool. Let's quickly see the code. It's pretty simple. As I showed you, I will have my answer, which will say how many batteries, or basically these things I have tested, and I'll go on from left to right on all my battery percentage. At this current battery of I'll subtract the number of batteries taken as I showed you previously. If that is more than 0, which means I can test this. Okay, that is great. I can test this and simply increase my answer as I showed in a dry run also, and simply return the answer. With that, in O of n, you can simply get this solved. Else the brute force was O of n square, which I showed you previously. Cool. Let's quickly jump on to question number 2. Meanwhile, we'll just have a quick chat read. Hello. Hi, Vamsi. Hi, just woke up right now. Aryan, good morning, Vamsi. Shashank Davari, bro, there was a solution discussion of question during contest. Can you please mute group during contest? Sure. I did not look on what you guys were discussing. Anyone doing contest? Yes, giving second, third. Give me 2 second word. Handle the modular exponentiation. Why it is doing cancel? Handle the modular exponentiation carefully. Give me that too. In test cases are not working. It is showing for me. Second, giving me anyone doing contest. Okay. Third one is same as yesterday bi-weekly. Third contest, little bit of modification. But now you do cover all the substrings. I'm using 2.1, confused about moving the window. Once maximum increase. Yeah, this should not be done. But it is okay. See, don't share the approaches. Like, you can just discuss about things like, okay, if the website is not working, something like that. But don't do this stuff. That would actually like indicates like you're just sharing your approach, because as I told you in the beginning also, there are 5 steps for any problem completion. So maybe you have reached the step 3, but maybe you are just directly making a person hop from a step 1 to step 3 without making him even think of step 2. So I'll say that, oh, what's wrong in the second one? While computing power, you need to take, yeah, see, don't ask wrong and stuff. See, contest, see, I can for sure mute it, but one thing is that you guys have to understand, it's good for you. Contests are good for you itself, and post contest, if you realize your mistake, that's much better than just asking for help while contest, in the contest. Okay, so I'll make sure that cool. Let's quickly, Aryan, please share Telegram link in chat. I'll join. Telegram link is in description. You can just go and check that. Vamsi, cool. We'll go on to question number 2. Again, that's a pretty basic question. But yeah, meanwhile, if the folks are here, can we please, like, if the regular folks are here, if you are new, so you can just watch the videos entirely and maybe in the end you can like it. But if the regular folks are here, we can please smash that like, baby. Cool. Now it just says number modular exponentiation, as I told earlier also. Rest all problems are just smaller descriptions. The first one was the largest. Cool. We are having a 2D array variables where variables of I is AI, BI, CI, and MI. It just says that I have array of these variables. Now I have to compute this. When I say compute, okay, I'll just say this is a, this is a B, this is a C, this is a M. Compute A raised to the power B mod 10 raised to the power C mod M. If this value, which means when I say compute this variable of I, compute, which means find this value, which is simply nothing but modulo exponentiation. Simply nothing but modulo exponentiation. If you don't remember modulo exponentiation, remember this at your fingertips. Firstly, you will have, when I say LL, I say long, you have your answer initialized by 1. I ask you compute A mod A raised to the power B mod M. I ask you compute A raised to the power B mod M. You will just say, okay, why your B is there? If your B right now is odd, if your B is odd, simply do one thing, that in your answer you can simply multiply by A. And whenever you do any multiplication operation, make sure you just do modulo by M. And you just did multiply by A just once, so simply decrease your B by 1 only. Else, which means your B is even. If your B is even, okay, you can just, instead of multiplying your A in the answer, multiply A by itself. And again, at any multiplication operation, do a mod M. And again here, B will reduce by half because you are multiplying A by 2. And then ultimately when this is done, simply return the answer. That's a simple modulo code which you always should remember. It should be at your fingertips. Cool. And we'll just simply use this code to compute firstly this value, where I'll do a raised to the power B mod M. Now this will become the new A raised to the power C mod M, will be again computed using the same function. So you will see I just made this function as I wrote above also, exactly same. See again, that's a simple modular exponentiation which is widely used to compute A raised to the power B mod M. Right now, as I showed you, I will find A, B, C, and M. I'll just compute A raised to the power B. A raised to the power B mod 10, that is my new A raised to the power C mod M, that's my new value, which is val. If that val is equal to my target, then I'll just push back my correct index in my answer, and with that I can just simply get this solved. Cool. So that was a very basic question, just simply applying your template or your formula. We have discussed the same binary exponentiation code many times in the live streams also, and also in the daily problems. Cool. Now we'll quickly go on to question number 3. Again, at any point you have any confusion whatsoever, I know that I have started live stream a bit early today. Again, as I mentioned, I had some work, critical task to do in office. But again, if you have any doubts whatsoever, you can just comment down below. Later in the post, I'll just try to reply them. And also the contest was not that much hard, so yeah, that also will work. Count sub-arrays where the maximum element appears at least k times. Again, sub-arrays, there was a question yesterday also of sub-arrays. If you don't remember, I'll show you. So okay, that's a question number 4. Question number 3. See, length of the longest sub-array with the most frequency. You will see that we will roughly do the same stuff. Just have a snapshot of this code and we'll be doing the same stuff, because the question also more or less is same. Cool. That's the reason I told you, like, the question was more or less same to exactly yesterday's question. You are given an integer array nums and a positive integer k. Return the number of sub-arrays. The same thing which we had to find yesterday also, right? Number of sub-arrays where the maximum element of nums appear at least k times. Now, let's say the maximum element of nums is x, right? This, I just have to make sure that this x should appear at least k times, which means at least k, which means okay, k or more than k. More than k is always good for me. Just okay, it should be k. So first basic task which I should do is just go and find this x, which is the maximum element. Here and that's very easy. You can just apply, there are many STL, or you can just simply iterate on also. Just go and find the maximum element. Here the maximum element is 3. Okay, now my x is 3. Now I just have to make sure at every again, I have to make sure that all of my sub arrays which I will form should have frequency of at least k. Now, yesterday also we had the same task, right? Yesterday also we had the same task. In that, we just have to maintain the frequency of each element in the array should be less than or equal to k. Now, I am just mentioning here the frequency of the x, which is this one element, should be there. So again, I will just keep on maintaining the frequency, and I can just use the same sliding window approach. So if I just take the same example, 1 3 2 3 3, I can, as I do simple in a sliding window, I will have my I and a j, and as I have my I and j, I will also have my map. Map will keep my count. Now I will have to keep on increasing, which means I will only add in my answer. Let's say my answer is the number of subarrays. I will only add in my answer the number of subarrays only when actually my map of x should be greater than equal to k. Should be greater than equal to k. Only then I can add in my answer, right? So okay, right now I cannot add. Okay, cool. And as I showed also previously, at every point I will just keep on incrementing my j, because j will keep on moving. I will try to cover up, right? Okay, j was here. Okay, my map of 3, the count of 3 is 0. Okay, cool. J moved here, count of 3 1, that's still not 2. Okay, cool. Map of 2, okay, increased to 1, but still the map of 3 is still a 1. Okay, cool. Again, keep on moving. J, map of 3 2. Oh bro, map of 3 is 2 now. Map of 3 is 2 now. Wow, that seems great. Now map of 3 is 2. Now if I, okay, now first thing is for sure this I to j is a good subarray for you, but now I am asking you, that is a good, right? You were about to add in your answer when you were saying, okay, you will add in your answer when your map of this x is 3. Now it is more than equal to k. It is more than equal to k, which is more than equal to 2. So you will add in your answer, but I'll ask you, how much should you add? I did not say the count should be k. I said it was at least k, which means if I consider this as a subarray, anything after this will always be good, right? Always be good. So if I know my entire length is n, if my j is ending here, and I know it's I is here, so it's a unique subarray. So all of the subarrays which will start from I up till the j like this, j like this, j like this, so on and so forth, will be a good subarray, because this has a count of 2. So no matter what, your count will always be keep on increasing. It will never decrease. So again, if I just put the indexes, which is id equal to 0 1 2 3 4, I can just say that my n was actually a 5. 1 2 3 4 5. So n minus I simply add n minus I in my answer. N minus I will indicate, okay, for this I and j combination, number of subarrays at least who have at least k as a frequency of the maximum element are actually n minus I. Now, do you remember one thing? Okay, when this is done, when something is good, earlier in the previous example it was bad, so I was shrinking entirely, but here it is good, right? It is good. So shall I shrink? Yeah, for sure. At one point you have to shrink, right? You will have to shrink. Earlier we were shrinking on the basis of it was bad. Now we are shrinking on the basis of it is good, because we wanted all of our subarrays. So I'll just try to shrink it. Okay, if I just shrink it, I'll just move this ahead. When I say shrink, I'll just move my I. As I move my I, frequency of 1 has decreased, but still I'm just concerned about the frequency of x. That's it. It is still more than equal to 2. So now I have got a new combination. It's again a great. So again, all these will be great. Again, add again n minus I. So you remember n minus I. 5 minus 3 was 2. So you added a 2 by the previous logic. Now again for this, again it was 5 minus 3. Again you added 2. As simple as that. Okay, cool. Now you will again try to shrink it. Okay, you will try to shrink it. Now your I is here. When you try to shrink it, map of 3, which means the count of 3 is now 1, which is not this case. Your count should have been more than equal to 2. It is now 1. Okay, now you cannot add in your answer. Simply go ahead. Okay, I'll just simply go ahead. Go ahead. 3, map of 3 has again increased to 2. Now it's again a good. Okay, it's again good. No worries. I just have this. I remembered my n was 5. So for sure, 5 minus 1 is 4. Sorry, 5 minus 4 is 1. Okay, I know I will have one good subarray with this. Okay, cool. Now again try to shrink it. Again I try to shrink it. Okay, I'll come here. Map of 2 will reduce to 0, but still map of 3 count is again a 2. So again that is good. Again that is good. Okay, cool. Simply add 5 n minus I, n minus n minus j, which is actually 1. I added that. Again try to shrink it. Okay, cool. Again count of 3 has become 1. Cool. I cannot add in my answer anymore. Okay, cool. Go ahead. J. Oh, your j has reached the end. Simply it is your answer, which is 6, and that was your answer. Cool. It's the same stuff which we have done yesterday also. Let's quickly see the code. I will have same I and j pointers, and for my nums dot size. Now this max I is the maximum element, or basically the xi represented in the code. So firstly I just went and found out the maximum element. Then as I did yesterday also, I just went on to my I just will iterate on and say, okay, until my j is less than my nums dot size, I'll firstly, as I land onto a j, I will include that in my answer, right? So I'll just include, okay, I'll just say the frequency, or basically the count of that nums of j has been increased by 1. Now I will try to shrink. Basically I'll just try to check firstly if my count, or basically map of maximum element, if it is more than equal to k, then only add n minus j in your answer. And when you have added it, just try shrinking your I. Again, when I say I'll shrink my I will increase my I pointer, but before increasing, decrease its frequency also. Okay, I'll do this stuff and I'll just try to shrink. Again, I will go and check if it is more than equal to k. Again, simply go and add n minus j. Again, try to shrink your I and keep on going. If it is not possible, no worries, bro. Simply increase your j. You will see you are only adding in your answer only when you have said that the count of that maximum element, or basically the frequency of the maximum element, is more than equal to k. Only then you are adding in your answer, right? And then ultimately with this approach, you can simply, and again you will just have a look at that code. You will see that the code looks more or less same, and that is how sliding window also works. Cool. With this you can just solve it in O of n time and O of 1 space. So with this you can, and like you might say, this unordered map might take a space, so yeah, that will take a space, so you can just take it as an O of n space. Cool. With this we have solved question number 3. We'll quickly go on to question number 4, but before that, if you have any doubts whatsoever, hello, hi J partner, if we do that directly, what will happen instead of using that modulo function? It might go out of bounds, no? So if we are not using modulo, let's say if you just look at the constraints, your A and B and C, it is 1E3. So if I just do a 1000 raised to the power 1000, you won't even imagine how big number this is. See, 1000 raised to the power 10. I just did only 10, not even 1000. I just did only 10. It is 1E300. 1000 raised to the power 100 itself is 1E300, which means 10 raised to the power 300. So yeah, that is why you know that you cannot do actual simple A raised to the power B. You have to do modulo M at every point of time. Cool. Cool. If the folks are watching in, if the regular folks are watching in, or if the new folks have joined and if they have liked the stuff, meanwhile, can we please smash that like baby? We'll go on to question number 4 very quickly. And if the regular folks are there, just the standard stuff, smash that like baby, because you don't have baby, I don't have baby. We both are smashing only the like baby, right? Cool. Count the number of good partitions. Any other questions by anyone? But yeah, how we can solve the questions as like you solve the questions very early. Can you guide me, Manu? What's see, it's entirely about practice and seeing the same question. Like for sure, I have taught you, I have seen the same question like this, which we saw question number 3 around 50 times or more than that. So it's that logic. Okay. And for me, like there's a kind of a weakness of mine. 2 pointers and sliding window are a bit on a weak side when I code them up. I can think of the logic, but while coding, I just usually miss my pointers or something like that. So on the coding, it is a bit slow. I know I know the best part, which I think is you should be knowing your weakness also. So I know that's my weakness. I know that I need to work on the coding, which means my speed should be fast, because logic every time I know for sure, because I know I have been teaching it. Logic, I have been knowing it. And it's very easy. It's just at the glance of the question, I know the logic is this. It's just that for me, coding part takes time of sliding window and 2 pointers. While for the other questions of DP, let's say graph, it's very like fast in comparison to sliding window and 2 pointers. That is a thing which I have told previously also, but it only comes by practice itself. So there's nothing which we can do. It's just that we see more questions, we solve more questions, we solve more patterns, we figure out more patterns, we try to figure out what things can happen, all that stuff. Cool. Let's go into question number 4. Count the number of good partitions. Now it just says that you are given a zero indexed array nums consisting of positive integers. A partition of an array into one or more continuous sub array is called good if no two sub arrays contain the same order. The only thing which is important is we have to partition the array. Again, when I say partition, I mean that I'll just have it something like this, which means all of the elements should be included. Ultimately, when I say I just do a partition. Now this partition has a speciality. What is the speciality of this specific partition? It is that no two sub arrays contain the same number, which means if a number is 2, so another number 2 should not come in a different sub array. So it means it indirectly means that if a number is 2, so it should come inside the same sub array. It should come inside the same, and that's the only point of this entire question. That's the only crux. That's it. I'll show you with example itself, but yeah, that's the only crux. Cool. Return the total number of good partitions of nums. Right, that is it. Now firstly, if we have to imagine this thing, okay, right now we have seen, but bhaiya, how we will bifurcate these all sub arrays, because a partition of an array into multiple continuous, so basically this is one partition, right? Basically, yeah, it is one such partition. I have to figure out all such partitions possible, and it just says the partition is nothing but continuous sub arrays. And how they define continuous subarrays partition as good? When two subarrays don't have the same element. I'll try, and so their main point is this thing, same number or the same element. So I'll just try the same stuff. I am writing alphabets, but remember them as numbers, right? So okay, if I have a I have a A. One thing I know for sure, that these two should be in the same subarray. Again, these two should be in the same subarray. Again, you can have a very big subarray, like very big array, but I'm just bringing and trying to boil the problem down to a smaller problem. Okay, let's say if I would have a B and a B, right? Again, this should be in a same subarray. I am saying this should be in a same subarray. I am saying this should be in a same subarray. This should also be in the same subarray. So for sure, this entire thing should be in the same subarray, right? Now, okay, that is good. Now let's say if I just ask you, if I have a D, let's say if I have a E, let's say if I have a F. So you will say, okay, that is not impacted. My D can be in my one subarray. It should be in the one subarray. It can be in other subarray. So basically you try to bifurcate your problem like this. Like you had your main subarray, you had your main array, you bifurcated that to all these subarrays. Now how you did that? You just made sure that my same number should come in one subarray. That is what you wanted, and that is what you did also. That your same number is coming in one subarray. That is what you did. Okay. Now you have made one partition, one such partition. But if you just look very closely, it is the most distributed partition ever you will be able to make. Which means you cannot further break this partition down anymore. You cannot break it here, which means you cannot make this E or this E, because E will be same characters or same numbers, and they should occur in the same subarray. You cannot break like this, you cannot break like this or this, because for sure this is the most distributed sub array or basically partition which you would ever make. So basically you can just imagine this as your base case. Now I have this base case. So now rather than, okay, I know I have these 4 sub arrays with me. Okay, now imagine this, okay, so basically, like you can see, that person is calling. Again, as I showed you that I had to go and do work, so probably I'll end the live stream a bit early, but yeah, cool. But yeah, explanation will always be top notch. Cool. Now, so basically we have bifurcated to all these 4 subarrays. That's great. Now, if I just boil it down, okay, I have this one subarray, other subarray, other subarray, and other subarray. For sure, this is the most distributed partition which I could have. Now comes the interesting part. Now, it was one such partition. I can club these 2 partition and make one subarray, right? Okay, sub call karenge ab. Cool. I can make these 2 partitions. I can take these 2 partitions, so these 2 subarrays, and make one subarray. Now, why that will be good? Because for sure this was having no same elements, so basically all same elements. It was having all same elements. If I just club them up, for sure still it will satisfy the condition, which is it will have same numbers in the same groups. That is for sure. I'm just clubbing the subarray itself, and subarray in itself is good. It's good. So I just got to know one thing. I can just club my subarrays. So if I can get this count, if for a partition I can get this count. If for a partition I can get this count, okay, how many number of subarrays I can distribute at max, which is 4 in this case. So I would know one thing for sure, that okay, for 4 my answer will be a 8. Now bhaiya, how? Okay, I got to understand that you will distribute your entire array to all these small subarrays, which is the minimum possible partition you could ever achieve. You will do that. That is okay for us. But if I have achieved this, let's say if I have achieved A, B, C, D, again, like let's imagine that one particular subarray I named it as A, and then again I named it as E, B, C, and D. Let's say I name like this. If I name like this, I'm getting continuous calls. That's giving me cool. Now what will happen with this is that you have this, and now I'm asking you, you can club any of them. You can have a A, B together, you can have a C, D. When I say together, I mean, okay, you can club A, B, you can have a C, D, and so on and so forth. You can have multiple such ways. That's great. But how many number of such ways? That's a question. So in this case, when you have to find the number, we have boiled the problem down to a smaller problem, but now we have to find the number. Again, just do one thing. Just imagine this as small problem. If you had only one partition, okay, that's the only case, which is A. If you had A and B, then what you will do is, okay, you can have A and B as separate, or you can just club them together. Basically, if I think of in the perspective of B has 2 options. Either he should club with the whatsoever left has been made, or he can remain alone. Here he remained alone, or he clubbed with the previous ones. Okay, let's say if I add a C also. So again, C will have 2 options. Either he can get clubbed with whatsoever AB has made, or he can remain alone from whatsoever AB has made. So if I can, and I know that AB can make this. So I know that AB can make either clubbing or like this. AB can make either clubbing or like this. Again, C here will attach. C here will remain away. Because for sure C will have 2 options. Okay, if we expand the case, let's say A, B, C, and D, again D will have 2 options. Either he should attach with whatsoever previously have been made, or he should remain away. If we attach, so I know I have 4 ways. Okay, I'll just push these 4 ways. I can push these 4 ways. So you saw that it is kind of increasing in the powers of 2. I have 2 ways. Again, because for V it has 2 ways, either attach or not attach. For C it has 2 ways, attach, not attach. D has 2 ways, attach, not attach. So you saw, if I can make 4 groups, my answer will be 2 raised to the power 4 minus 1, which is 2 raised to the power 3, and that was your answer, which is 8. Just simply make sure, do a modulo, which is, you know, you have 3 groups, so do a 2 raised to the power 4, sorry, you have 4 groups, do a 2 raised to the power 4 minus 1 mod of this particular mod value, and that's your answer. Simple. So now, okay, ultimately you have reached the entire conclusion. Now comes the coding part. How will you code? And the coding part is itself just figuring out these number of, or basically the count of groups. How will you figure the count of groups out? Okay, that is again a good question. Again, we just want one thing. The only thing which will hinder us is that if I have something like this, okay, B or B, so I should be knowing, okay, I will consider this one group when, okay, I will be starting from this, let's say I, then I should know what is the last index of that specific character B. So I will know the last index is, so one thing I got to know, I will have to maintain the last index of every character, because I will go on from left to right, so I will have to maintain, or basically I will have to keep track of the last index of every character, because I will just say, okay, reach there, okay, my J is here. Now for sure I can make a group with this I and J, but I am saying I can, I'm not saying I will, I'm saying I can, because, and then when I will just keep on iterating on my I, this, when I'm at this I, he will say, bro, my last is beyond this, so I'll update my J to the last. Okay, then again keep on going. Let's say if I encounter again as G and G and something like that, so what will happen is again you will keep on going. I last was itself here, so no worries, keep on incrementing. See, your J will just point to the last of that specific ith character. So basically your J will always pointing to the last. Okay, your I is here, and I just keep on incrementing. Okay, at one point I will be here, J could never exceed, because J was only exceeding for that specific ith character's last position. I was pushing my J. Okay, now I cannot push my J any forward, so increase my I. Now at this point you will see that your I has exceeded your J, and that is just an indication that, okay, for sure you have made one group previously which was a good group, which was a good group. So okay, I just increment my count of group by 1. So this will make me sure that, okay, it's a good group. Let's try run how this count of group will look like. I will have my J in I and J in the beginning, right? Okay, again my J will only increment on the basis of my last location of the ith index value. Cool. Now I will just have your I and J. I'll just simple, I will always keep on increasing 1 as in a simple sliding window happens. Your one pointer will always keep on increasing, other pointer will try to shrink or adjust according to the other pointer. That's how a sliding window approach works. Cool. So what I will do is I will simply know, okay, my J, I'll ask, shall I increase my J? So he will say, bro, one thing, your I, which means F's last location is this itself, so your J will remain here. Okay, cool, J remained here. I'll move my I, because I will move it every step. Oh, I have got a situation where I is more than J, for sure. Again, that's a good group. Okay, I have got a good group count as 1. Cool. Now my J is here. Okay, now I is here. Again, I's corresponding character is E, so simply move your J to the last location of E, last location of G. I'll move. Okay, cool. Now, okay, I'll only add in my count of good groups when I is more than J. Remember that fact, because that is how indicates that I have surpassed my limitations of being in a group, right? Okay, cool. I'll increase my I. Again, it's same. Cool. No, I'll increase my I. Oh yeah, I was easily able to increase my I. Yeah, okay. Increase the count 2. Okay, cool. Now as you were at I, you will just try to point your J to the last location of D. Last location of D is this itself. Okay, your J will point here. Again, I'll try to increase my I. I'll increase my I. Your J is again here. Okay, yeah, that condition is satisfied. Count of good groups is 3. Okay, cool. Move ahead. Your J is here now, but B's last location is this. Okay, cool. Your J will point here. Cool. Move ahead. A's last location is this. Okay, cool. J will point here. Cool. Move ahead. Okay, B's last location is this, but still My j will never come back. It will only be on the right side. Okay, cool. So move ahead. Still j will remain here. Cool. Move ahead. Again, I have got a good. So simply increase your count. Okay, g is last location. Okay, j will move ahead. Cool. I'll say I will move ahead, and then ultimately I will move ahead. Okay, I has reached the end, super end, no point. So you will see that last group was not counted. So in the end, add up +1 because this last group was not counted for you, right? Because as soon as the I ends, your loop will end because you were adding these things in the loop itself, right? And as your I exceeds, your loop will end. So make sure that in the end, you will add a +1 because the last group was not counted. So as to get a count of all the groups, all the subarrays. Now we have got, okay, my total number of groups are 5, 1, 2, 3, 4, and 5. Answer will be 2 raised to the power group -1 mod m. And that we will do same by using the modular multiplication. Let's quickly see the code. It's same, pretty simple. Here I use the exact same code of modular multiplication. As I showed you in the beginning also, I will keep track of the last location of every number. For every number, you will see, for every number, I am keeping track of the last location. Cool. I am keeping track of the last location of every number. Now, when this is done, simply you will have the count of groups, which you have to get the count of groups. As I showed you, I will move my I. As simple as I'll simply move my I. I'm focused only on moving my I. I will increase my count of groups only when my I is more than j, as I showed you in the dry run also. I'll add a 1 in my count of groups only when my I is more than j. And for sure, always update your j with the maximum j of that specific ith number, where that specific element at the ith location's last value. Update your j with the maximum j, and with that you will get the maximum j. And again, this will keep on going and will count the count of groups which you have. And as I showed you also in the last, that you will increase the count of groups because in the loop your I will end, so your last group would not be counted. So with this fact you have got the count of all the groups, right? And ultimately your answer was 2 raised to the power groups -1 mod m, and that is your answer. You can simply return the answer, and with this you can easily get this solved. Cool. We'll go on to the comments. Any doubts whatsoever, you can just go and ask. Yep. And cool. Today's live stream is of one-time complexity. It means very fast. Yeah, true. I have got a lot of phone calls which I have to attend right now after the contest because I have quite a lot of work pending. Cool. Cool. Aryan, I'll join. If we do writing, then what will happen instead of modular? I showed you, भैया, how can we solve that's done? 2 while लगाने के बाद भी O of n कैसे है? Which one? Oh, this one. See, it is never, as I showed you, it is a 2-pointer approach. This is increasing only your j pointer. See, this is increasing only your j pointer. This is increasing only your I pointer. J will move for sure n, I will move for sure n, and they're only moving forward n and n. That is the reason the time complexity is O of n plus n. Again, that is not, this while loop is not for every of these j's. Ultimately, in total, your I will move to n steps and j will move to n steps. That is how a sliding window works. Cool. Fast, bro, literally Q2 was irritating, was getting runtime. Yeah, like runtime error. Yeah, that happens a lot with me also. And you can't even imagine, I do such silly mistakes, like many wrong submissions I have done only because I have not seen the constraints limit properly and I got integer overflow or something like that, which is pathetic. I don't like that. Bro, this Q mesmerizing may snake game. Bro, this Q mesmerizing may snake game. Bro, this Q Mesmerizing Miss Nick game. I thought was going to start at 11. Yeah, that is the Ritik in the beginning. I just mentioned like, basically today's live stream. Usually we start at 11, but today's live stream, like I have to go and do some urgent task. That's super critical, but still I am just doing live stream. That's not okay, but I will have to do it. Cool. Bye Aryan. Yippee Sunday with office work. Yeah, true, Vamsi. Good explanation, bhaiya. No any doubt. Great, Manu. How do you manage YouTube along with office work? That's it. Like if you just see, and like if you want to go and look at the lifestyle, like I am just alive on bananas. Like I have not yet eaten since yesterday because I could not get time. In the end we had this, so I just have these bananas and probably I'll go and work, and probably while working I'll eat. That is how things go. Like although in other firms it's not much hectic, but it depends upon the workload. Cool. Yeah, that is Anik. Thanks for this session. Even you are too busy. Like usually I'm not, but lately it has been blown up because I'm trying to manage. If you just don't know that, we are just trying to have this amazing kind of interesting reels concept on our Instagram. So we try to post daily here. We tried on YouTube initially, but there can be a bit copyright issues on music which I use for the specific videos. So I just planned, okay, I'll just only post on Insta, and we post that daily at 11 o'clock, which means 11 has passed. But I will, after this live stream, I will do another post of today's. So every day we post fun, interesting coding concept, or basically anything which will help you in tech, or basically if other thing like other can be a worst case meme which I relate to. So yeah, that is how we actually just get awareness distributed via memes. Cool. Cool. Code and code. It's amortized OFN solution, bro. Yeah, that's true. Code and code, respect bro, respect. Cool. Bye. This weekly contest is a bit easier than the other ones at Leetcode. Yeah, that is true. Easy peasy DSA, easy.pz.dsa. It is easy.pz.dsa. Easy peasy DSA. Cool. Thank you so much for watching. Thank you so much for turning in, and yeah, see you guys in the next video. Okay, how to do this. Cool. Thank you so much for watching. Again, anything whatsoever you guys have, want, discuss, tell, do, just comment down below. We will be super happy. Banana, like, oh, for sure, I'm a guy. So cool. Cool. Thank you so much for watching. Cool. We'll see you tomorrow. For sure, tomorrow. And yeah, today's contest, Sahil, hello, hi Sahil, Aryan sir, Ors, cool. Thank you so much. And again, I did not bring today's problem of Leetcode daily because it's super easy. It's just mapping your row. So basically, if you have a matrix, let's say mat, so you have to just map mat r comma rc to a cr. Just like that. So if you just iterate for I from 0 to n, j from 0 to n, just simply map your row, which is simple map, like your answer of column R, which is CR, will be nothing but your existing matrix mat R column. That is how a transformation, or basically a transform of a matrix is happened. Aryan, I have a doubt how competitive coders get the idea faster than the normal. They just solve without pen and paper. See, competitive coding, again, many problems. If you will start coding more frequently, there's no term as competitive coders do this more frequently. Even if you will see many people on Leetcode submit very fast, which means they don't have time to even pick up the pen and paper, because as you start reading problem itself, now you will start to figure out the patterns and you will start to relate with the existing problem. And that's, you know, okay, you for sure know pen and paper is required when you have to build and when you have to dry run, which means when you are seeing the problem for the first time. But for the coders who just do coding more frequently, for them it is very natural to just know the problem pre-hand, because you cannot build a problem out of nowhere. It still can happen, it still happens, but yeah, for the easy ones, it's just more or less modification of any existing problems. That's how coders do it. Cool, Vamsi, it is all about practice. That's true, Ritik. Cool. Thank you so much for watching. See you guys next video. Until then, goodbye. Take care. Bye. Cool. I hope that this live is correct. Cool. Thank you. Bye. And yeah, before going, can we please smash that like, baby? Yeah, you have, because of Hari, I just forgot to even ask you. Can we please at least smash that like, baby, to 30 likes? Like, yeah, you guys are regular, we are regular. Yeah, please. I did not, like, with this like work and stuff, I forgot to even ask you. Yeah, when I don't ask you, you guys will not do it. It is not fair, right? You will have to do it. Just smash that like, baby. Smash it. Finish your laptop. I'll also finish my laptop. But yeah, let's smash it. And yeah, cool. Thank you so much for watching. Please smash that like, baby. Bye.